Hey, this is Horner. We're going to look at number 52 through the end of the kinematics packet. Number 52, they want to know what is the acceleration at 5 seconds, and we know that this one has got to be letter C because at 5 seconds that's our slope. So at 5 seconds our slope here is 2. Number 53. They want to know how far is the clown gone. This answer is 74 because if you were to find the area under the line, then you would find out that you would have a value of 74. So at 12 seconds, you'd have to find the area of this whole thing. So you just have to break it up. Here's a triangle, here's a rectangle, here's a little triangle here. You could do a great big rectangle here. You just have to break it up and do it that way. For number 54, the answer to this one is D. That one should be pretty obvious. The acceleration is constant since there's a vacuum. For number 55, this one, you should get letter B. And it's because a projectile launched at a smaller angle, does not have to go as high and will fall to the ground first. For number 56, this one says, oops, went a little bit too far here. For number 56, you've got this graph and they want to know a couple things. They want to know where does the marble have a negative velocity. So that would be letter D. And it's because at these different points, so from about 4.8 to 6.2, you'll see that it's got a negative slope, and then from 6.9, which is somewhere around here, to about 10 seconds, you'll see that this has a negative slope, and so does this one. So that's a negative velocity since this is position versus time. They want to know when does it have a positive acceleration. Remember, that's anytime that you see a smiley face. So the ones that you're going to have is going to be letter D. So you've got a smiley face here, got a smiley face right here. So that is that's another one. So from 2 to 2.5, from 5.8 to 6.2, and then you've got another one here from 8.8 to 8.4. So anywhere you see the smiley face, we know that that is a positive acceleration. And that's number 57. For number 58, your answer for number 58, so let's move on to number 58. What is the marble's average acceleration between 3.1 and 3.8? So for number 58, you should get A, and because remember acceleration is just change of velocity over change in time, so that's going to be negative 2. 5960, more graphing stuff. They want to know what's the acceleration of the toy car at 4 seconds. So your answer for number 59 should be letter C. It is positive 1 meter per second. For the next one, which is number 60, the answer to number 60 is B. So the displacement here for the entire 10-second interval, you'd have to find the area here and the area here, and then subtract the two since this one's negative, or just add the two. If this one's negative and that one's positive, you should end up with 6.5 meters. For number 61, that's the next one. Your answer is letter B. An object is thrown upwards. After 2 seconds, what is the direction of displacement, velocity, and acceleration? The acceleration has to be down. So those two answers are good. These two answers, we can't have at all. And then in order to choose number 61, it is B. And it's because your displacement is up and your velocity is still up there. For number 62, the answer is letter D, graphs 1 and 4. They want to know if it has a constant speed. So that's got to be graphs 1 and 4. So that's this one and this one. For number 63 and 64, they both go with the picture that you have here. 63 wants to know what is the average speed of the ball between 3 and 4 seconds. So for number 63, the average speed is the total distance divided by that total time. So that would be 7 centimeters divided by 1 second. So you have 7 centimeters here. We divide by the 1 second, and you should get answer B. Which of the following is closest to the acceleration of the ball? So for number 64, at any point we could say D is equal to 1/2 AT squared. And if you solve for that for number 64, you should end up with letter C, 2 centimeters per second squared. Next one, number 65. This one, you've got these three different stones. They're talking about these. They want to know rank from high to low, the maximum height of each stone that is thrown. So here, the maximum height of the projectile is found from knowing that Vy is equal to 0 meters per second at the max height. So I know that if we use the equation for number 65, 0 squared is equal to the v squared plus 2gh, and I know the original speed, we can just find the height as v squared all over 2g. Mass here does not matter, so it's irrelevant. So the one with the highest initial speed should go the highest, and so that's going to be letter C. And so that'd be 3, then 2, then 1, and because it's dependent upon the speed itself. For number 66, they want to know what will be the time between the second and the third bounce. So if I used d is equal to 1/2 at squared, that shows the height is proportional to the time squared. So 1/2 the maximum height, so 1/2 the height is equal to 1 over the square root of 2 times the time. And then that would give you your answer. For the next one, which is number 67, so let's move this down a little bit. For number 67, if I can get this to move down, for number 67, your answer should be letter A. And it's letter A because we know that your final velocity is 0. So our original velocity, so we can say final velocity is 0 squared is equal to my original velocity squared plus 2 times A times D. That then gives us D, which is equal to V squared all over 2 times A. And if you do that math, you should end up with something's about 4 times as far. So if it was traveling twice as fast, it would go 4 times as far. Number 68, your answer here is letter B. Moving away from the origin will maintain a negative position and velocity. So slowing down indicates the acceleration is in the opposite direction. So that's why these are negative and that is positive because your acceleration is in the opposite direction. For number 69, your answer for this one should be letter A. The distance between the rocks increases while both are falling. That's just something that we've talked about lots of times. As something falls, your distance at each second. So this would be 1 second, 2 seconds, 3 seconds. Your distance gets bigger and bigger because the original speed here is always a little bit bigger than it is at the next point. So here your original speed is equal to 0. Here it's equal to a number. Here it's a number. Here it's a number. And because your acceleration is the same and these original speeds are continually get bigger, your distance will continually get bigger as you go through. For number 70, your answer should be letter B, and it's because we know that your final speed is 0, your original speed squared plus 2AD is the equation you'll use, and that means that your distance is equal to your original speed squared all over 2A. And so for number 70, your answer should be letter B. And it's initially moving at 1 meter per second here. So that's number 70. Let's go ahead and take a look at the next one, which is number 71. For number 71, for that angle of 120 degrees, there's a component of the acceleration that's perpendicular to the velocity, and that causes the direction to change in the component in the opposite direction of the velocity, causing it to slow down. So your answer here should be letter B. Its speed decreases, and it is changing direction of travel, and that's because it's turning in that circle. For numbers 72 and 73, they give you this diagram and you've got this thing turning. They want to know what's the direction of the average velocity during this time interval, so 72. So the average velocity is proportional to this displacement and the displacement is to the left. So your answer here for letter B should be to the left. Okay. And then it says, what is the direction of the average acceleration during this time interval? And so for this one, it's letter C, and that is straight down. The initial velocity, the velocity is initially pointing up, and the velocity points down. the acceleration is in the same direction as if I take the change in velocity, which is equal to the final velocity plus the negative original velocity that I have. Okay, so number 74 and number 75 are the next two. For number 74, they want to know what time is the car the greatest distance from the origin. So for 74, we know the car is the greatest distance just before it reverses direction at 5 seconds. So that's why the answer is B. And so if you think about it, that's the area right here. And so that's the biggest distance. It's still moving, still moving, still moving, same direction, same direction, same direction, and then it stops right here. They want to know what is the average speed of the car for the 10-second interval. So in order to find that average speed, the velocity is initially pointing up, and the final velocity points down. So, oh shoot, let's see. That's not right. The average, average speed here is equal to the total distance divided by the total time. So the total distance is the area that we have under the line, and the area below the t-axis is still considered positive. So for this one, you're going to end up with an average speed of about 5 meters per second. And that is how you do number 75. So let's go ahead and take a look at the next one, which is number 76. This is a position versus time graph, and they want to know for what time is speed of the object the greatest. And so for number 76, it is just the slope of the line, so it's going to be at time 4, because that's where the slope of the line is the biggest. For number 77, your answer should be letter A. Your acceleration should be pointing down, and because you are, when that thing has a trajectory, it kind of goes like this, so our velocity has got to be like that. Number 78, average speed, remember, is total distance over total time, so this one should be letter D. For number 79, which is our next one, this is the one about the two automobiles, and your answer for this one is letter A. Okay, and to find out how many hours they meet at, what we're going to do is the relative speed between the two cars is just the velocity of the first one minus the velocity of the second one. So that would be 60 minus, and the other one's going the other direction, so it's negative 40. And so that's equal to 100 kilometers per hour. So they'll meet when our time is equal to the distance divided by the relative speed. Our distance was 150 kilometers, and we're going to divide that by our speed, which is 100 kilometers per hour, and then that will give us our answer, which is letter A, 1.5 hours. For number 80, the answer here is D. Yes, an example would be a falling object in the presence of air resistance. So the acceleration can decrease if the velocity is still increasing, as long as you have that air resistance. For number 81 and 82, they're talking about this recent winter storm. As the bales are falling through the air, what happens to their distance of separation? And we've said this one several times, it will increase, because as things fall, their speed at these points, successive points, is bigger and bigger and bigger. For number 82, they want to know how far apart from each other. So here, the bales will travel at the speed of the plane, and gravity won't affect their horizontal motion. So when they land, we know that D is equal to V times T. So that's going to be equal to the 50 meters per second times the time. They're dropped 2 seconds apart, so that's going to be 2 seconds here. The seconds will cross off, and that means that they're 100 meters apart, and that's what you'll see. And so those are the solutions for number 52 all the way through number 82.